Hello, the name of our group is Creativity and Zeal. First of all, we greatly appreciate the efforts of three universities for this event, and we are thankful to have this opportunity to present what we believe is one of the most practical and cost-effective solutions for U.S. long-time challenge hypoxia in Gulf of Mexico. This presentation is structured as follows. First, brief introduction to problem of hypoxia, and then suggest a solution to the problem, and finally show step by step how we will estimate the cost required for this solution using Lake Bloomington, Illinois as an example. Introduction. The Mississippi River is the largest drainage system in the U.S. The watershed is larger than 3 million kilometers square, which covers 31 states and 2 Canadian provinces. The system slowly runs southward for about 2,300 miles to the Gulf of Mexico. Due to the size of the watershed, nutrients load into the river from a wide range of places, which is the main cause of hypoxia. Hypoxia refers to waters where the dissolved oxygen concentration is below 2 milligrams per liter, and aquatic organisms can no longer inhabit in that area. The largest hypoxic zone currently affecting the United States and the second largest hypoxic zone worldwide occurs in the northern Gulf of Mexico. To counteract the further expansion of hypoxic zone, we are proposing wetland as a solution. The solution is to divert nutrient-rich water into constructed wetland, let the wetland filter some of the nutrient, and have treated water flow out from the wetland and into Mississippi River. The main goal of this project is to estimate the size and construction cost of wetland needed for the Illinois River, which is one of the major tributaries of Mississippi River. There are two widely used methods to estimate the size of wetland. First method is using the ratio of watershed area to wetland size, and the second method is using ratio of volumetric flow of treating water to wetland size. Based on the result in executive summary, ratio of volumetric flow and wetland size is going to be used for this project. Now, using an example, we will show how we will estimate the cost of wetland. One of the successful projects regarding nutrient management highlighted by the EPA is Lake Bloomington Watershed Plan. Lake Bloomington is the main drinking water source for people in McLean County, Illinois. It serves about 70,000 customers. On the right side, it shows the map of Lake Bloomington watershed with land activity. In this picture, yellow represents the area where the corn is grown and green represents soybean. More than 90% of the watershed is being used for crop production. To grow the crop, it requires fertilizer, and for the case of Bloomington, it requires tremendous amount of fertilizers. These fertilizers are either transported to the lake through a tile drainage system or as surface runoffs during rainy season. Due to a massive load of nutrient into the lake, nitrate concentration of the lake exceeded the EPA standard of 10 milligrams per liter time to time. The city of Bloomington implemented constructed wetlands all over the watershed to filter nitrate before the nutrient-rich water goes straight into the lake. Before we go into calculation, we need to know what we want to treat. Money Creek is a major tributary of Lake Bloomington, and we knew treating water with high nitrate level is more efficient than treating diluted water. According to the Nature Conservancy, water from tile drainage had the highest nitrate concentration of 17 milligrams per liter, so our main focus is to treat tile water. Now we divided Money Creek into two flows, tile water and all other water. The U.S. Geological Survey has volumetric flow of Money Creek, and using Pinder and John's 1969 equation with nitrate concentration of all streams, we found about 60% of Money Creek is tile. With simple multiplication, we can estimate volumetric flow of tile water and all other water. In this case, flow of tile is about 9,000 and all other water about 6,000 gallons per minute. Now we have volumetric flows of 3 streams, and if we know nitrate concentration of at least 2 streams, the mass flow of nitrate going into the lake can be found. Based on data from City of Bloomington, nitrate concentration of Money Creek is 12 milligrams per liter and tile water 17 milligrams per liter. With simple multiplication with flow and concentration, we found 300 tons of nitrate per year goes to the lake as tile and 54 tons per year as other water. Here is the overview of the system. On the bottom left, we have tile and other water we talked about from previous slides. Now, we want to treat a fraction of tile water just enough to meet the EPA standard. A fraction of tile water goes to wetland as treat tile, and other tile water as untreated tile. Once treat tile comes out of the wetland, it becomes treated and reblends with untreated tile and other water. By the time it empties into the lake, final flow should have nitrate concentration below EPA standard. To estimate how much of tile needed to be treated, we need to know the nitrate removal efficiency of the wetland. Higher the efficiency, lower fraction of tile water that needs to be treated. If the efficiency is low, then higher fraction has to be treated. Based on 2 previous papers by Dr. Kovacic and Twait in 2006 and the Nature Conservancy in 2013, average nitrate removal efficiency was 45%. Using this percentage, we found about 80% of tile water is needed to be treated to have nitrate concentration of final flow of 8 milligrams per liter. To estimate the size of wetland, we will be using ratio flow to wetland size. Using 2 previous studies, ratio will be estimated. First wetland experiment was done by Dr. Kovacic and Twait in 2006. They built 2 wetlands adjacent to Lake Bloomington that received water from 6 cornfields. On the picture, white dotted line represents surface water and black dotted line represents tile water. The total size of 2 wetlands is 1.38 acres, and wetlands received 19.82 gallons per minute during 21-month study, and about 45% of nitrate mass is reduced after the wetland. Second wetland experiment was done by the Nature Conservancy in 2013. They built 3 wetlands for Franklin Farm in Lexington, Illinois that received water from cornfields. The total size of 3 wetlands is 14 acres. Wetlands received 125.08 gallons per minute during 2007 to 2013 study, and about 45% of nitrate mass is reduced after the wetland. Combining results from 2 studies, we can now estimate the size of wetland. The total size of experimental wetland is 15.38 acres and total flow received is 144 gallons per minute. To have nitrate concentration of final flow of 8 milligrams per liter, 80% of tile water is needed to be treated, which is equivalent to 7,700 gallons per minute. Using simple multiplication of ratio and tile water, about 820 acres of wetland is needed for Lake Bloomington. Finally, we can now estimate the construction cost of wetland based on the size. The Nature Conservancy has estimated that the construction cost of 1 acre of wetland is in between $3,100 to $3,600. To construct 820 acres of wetland, about $2.6 to $3 million is required. Assuming the location of construction is within the farming area, opportunity cost of growing corn has to be counted. From 2005 to 2011, the average profit from corn production is $214 per acre every year. Assuming 15 years of project, adding construction cost and opportunity cost, the total cost is in between $5.5 to $5.6 million. For another payment option, we looked into annual amortization. Assuming 15 years of project with 5% interest rate, annual construction cost is between $0.25 to $0.29 million. Adding annual opportunity cost of $0.17 million, the total cost comes out to be in between $6.3 to $6.9 million. Over 15 years, 1,500 tons of nitrate per year is going to be removed. So, about $3.6 to $3.95 is required to move every kilograms of nitrate. Here is the overview of our proposed project. Illinois River is one of major nutrient tributaries of Mississippi River, so we are only going to focus on Illinois River watershed. On the bottom left, starting from Illinois River, it is divided into tile water and other water. Now, we want to treat a fraction of tile water to meet the reduction goal. A fraction of tile water goes to wetland as treat tile, and other tile water as untreated tile. Once treat tile comes out from the wetland, it becomes treated and reblends with untreated tile and other water. By the time it empties into the Mississippi River, final flow should have nitrate concentration equal to the goal. To estimate how much of tile needed to be treated, we will use 45% nitrate removal efficiency. The purpose of this project is to reduce the amount of nutrient loading into Mississippi River from Illinois River. It has two main objectives. First, to estimate the size of wetland, and second, estimate the cost of wetland. What the group needs to do is to do more research on the characteristics of Illinois River and find 5 unknown factors. First, volumetric flow of Illinois River. Second, tile percentage, to know how much flow of Illinois River is from tile. And last, nitrate concentrations of Illinois River, tile water, and other water. To find more about the key findings from this presentation, refer to our executive summary. This project is not only beneficial for the community and the Illinois River watershed, but it can also be implemented into different watersheds throughout the Mississippi River watershed. This is the end of our presentation. Thank you.